Welcome to 12.3 probabilities. Today we're going to talk about when we're in a certain position, what the probability of certain events happening is. Now, probability is often described as the risk or chance of something happening. So, will it happen? Will it not happen? Also, it can be the ratio that measures the chances of it happening. So on that first slide, it said only so many people get struck by lightning. So here's the chances that it could occur. Now we're going to have two kinds of outcomes. So, for example, if you flip a coin, your desired outcome is called a success, while any other outcome is failure. And this is solely based on what you're looking for, what you're asked to find. So if you're flipping a coin and you want heads, then your heads is going to be your success because it's what you're wanting. And tails, therefore, will become your failure because tails is the other possible outcome. If I had a drawer and I had 3 different colors of socks, so say blue, yellow, and green, I'm asked to find the probability that I pull out a yellow sock, then a yellow will be my success because it's my desired outcome, it's what I want, and therefore my blue and my green will be failures. So it solely depends on what they're asking you and what the probability is that you're trying to find. Is it going to be a success? Okay, that's going to be your desired outcome, or is it going to be a failure, which is going to be the undesired outcome? It doesn't mean it's bad, it just means it's not what we're looking for. If there's one of the biggest things in probability that holds people back, or that if they don't understand, then it hurts them in every aspect, it's sample space. It's something that seems very easy. However, if you're not good at it, and if you don't have a full understanding of what sample space is, then the rest of probability is very difficult. The sample space is the total number of outcomes that can occur. And this is referring to when a simple event happens, or when any event happens. So if I roll a dice, a 6-sided dice, there are 6 total outcomes that can occur. That would be my sample space. If I flipped a coin, I have heads, I have tails, that's 2. My sample space would be 2. Why this is so important is that when it comes to probability is written as a fraction, and the sample space is on the bottom. So our total number of outcomes, possible outcomes, that number goes on the bottom, and then on the top you find your desired or your success. Okay, that's why when we flip a coin rather, and we say there's heads or tails, that's 2 possible outcomes. We're looking for the probability that it is heads. Heads, there is 1 possibility of flipping this and it becoming a heads. So that's why we say it's a 50-50 coin. It can go either way. It's 50% chance or a 0.5 probability. Okay, if I was rolling a dice and I needed a 3, the probability of me rolling a 3, there are 6 total outcomes. 3 is just one of them. So it'd be 1 in 6, or you can rewrite that as a decimal of 0.16 repeating. Notice this probability is under 1. And something that I failed to mention that I want to go back to on this previous slide is that the probability of an event occurring is between 0 and 1. The closer to 1, the more likely the event is to happen, and the closer to 0, the less likely it is to occur. And probability is always written as a decimal. Okay, so if we flip the coin like previously discussed, and it was a 0.5 probability, we say probability is equal to 0.5, but know that that's the same as saying 50%, or a 50% chance of that occurring. Okay, going back to the second example here, when there is a 3 on the die, a total of 6 possible numbers, okay, and if we're thinking about this, what the probability of rolling a number that's not a 3 Okay, so there's still 6 possibilities, 6-sided dice. All the numbers that are not a 3. Okay, we have 4, 5, 6. We have 1 and 2, so we have 1, 2, 3, 4, 5 of these. So it would be written as 5, 6, or you can take that as a decimal, which is 0.83 repeating. So what this is saying is the probability of not rolling a number, or of rolling a number that is not a 3, this is the probability. And if you're wanting a 3, here's the probability. Notice when you roll this dice, it can only be a 3 or not a 3. Those are our two options. That's success and failure. If we added these two numbers together, we would get a probability of 1. Okay, so that's going to bring us to a key point later on, that all of these probabilities should add up to 1. And looky there, it was really quick. Probability of success plus probability of failure is always 1. Okay, so that's what it's saying. There's a 100% chance of it being a success or a failure. One of the two. For the dice example, okay, we want to roll something that is less than 2, or it can be equal to 2. Okay, so this is how I'm going to note it. X is just going to say this is the outcome. This is what happens. So if I think about this, okay, the probability of it being less than or equal to 2 would be this set of numbers. It'd be 2 numbers out of 6, which would also be 0.33 repeating. Okay, so the probability of rolling it less than 2, I always draw this out. This is something that I do that helps me, and I say, here is the section I'm looking at. Here's my success. So that means that the other ones, the probability of failure, which is meaning that X is greater than or equal to 3, is going to be 4 out of 6, or 0.6 repeating. If you add these two decimals together, you get 1. So what this is saying is the probability of it being less than or equal to 2, or greater than or equal to 3, the probability of one of those happening is 1. It's 100%. It's going to happen. So probability of success plus probability of failure is equal to 1. Alright, so we're going to take this and we're going to extend it a little bit, and we're going to look at probability of spinning a spinner. So each of these spinners will be individual, and we're going to have to treat them such. When it says probability that it lands on red, so it's equally likely to land on either of these, meaning all of these are the same size. The blue and the yellow and the red are all the same size. Okay, so a probability of choosing a red is going to equal the number of reds, because that was our success, over our total outcomes, which was our sample space. Okay, so if you take this and you say number of reds, there's 3 reds on it. There's 8 possible outcomes, so our probability is 3 out of 8. You can write it as this fraction, or as the decimal version, which is 0.375. So the final step that really makes this look good is saying probability of red is 0.375. And that's our final answer. Okay, so it's always our successes, which means what are we looking for over our total. Now these spinners are a little bit more difficult to see on your paper, so I did put a yellow and a G, or a Y and a G, to show the different sections. If on your paper it does not have one of these, assume it is not that color. So if we're assuming that these are all equally likely and it lands on yellow, there is 1 chance out of, there's 8 sections, so it's 1 out of 8, or 0.125. This is a really good habit of getting into, to write this like this, probability of yellow being 0.125, probability of it landing on green. Okay, probability of green. there are 2 green sections out of the 8, which is the same as 1/4, so the probability of green is 0.25. Okay, I want you to do the next 2 examples on your own, so go ahead and hit pause at this point, complete them, and then play to resume, and I will go through them. Alright, notice on this spinner there are not white sections, so the 0 goes on top, there are 0 whites. On the bottom, your total outcomes are 8. This is the same as saying the probability is 0. The probability that it does not land on a red section, there's 3 red sections, that means that there's 5 that are not. Okay, so 5 that are not red, and 8 total outcomes, 5/8, and you can convert that to a decimal pretty quickly. Alright, the next thing we're going to talk about is complements. We're not going to use them a ton. We're going to talk about them and then a couple examples, and then wrap it up. So a complement, basically what it is if we're trying to find the probability of a certain event happening, the complement is the probability of the rest of it, the probability of other outcomes that are not the desired. This is also the same thing as saying it's the possibility or the probability of failure. Okay, so it's the other piece of it. We have a probability of it rolling heads, which would, if that's what we're looking for, then the complement is the probability of it being tails. Okay, so we use them. We're going to talk about we're going to use the dice example in class. We are going to move on to the next slide of how we use them. Alright, in this example, they show all of the total outcomes that can occur when you roll 2 dice. Say 36 are possible, so that we instantly know that that's going to be our sample space. If we're saying that the sum is not 2, okay, the sum is not 2, then if we figure out how many possibilities there are when the sum is 2, and we find that probability, and we take that away from 1, we'll find the remaining piece, which means the sum is not 2. So the probability of the sum being 2, there is here the sum is 2. That is the only way that the sum can be 2. So instead of counting up all these other ways, we can just find the probability of the sum being 2. So we have 1 minus, this probability of it being 2 is 1/36. So when we actually do this, you can do this on your calculator, you can do it with decimals, you find that probability to be 0.972, and that 2 repeats. So basically what we're doing is we're saying in order to find this probability, we know that this probability plus this probability will equal 1. So if we find the probability of this and we subtract it from 1, we'll find the probability of the larger area. So here we want the sum less than or equal to 10. Again, something I do to write this out is I say I want it less than or equal to 10. So that means I want it this way. It can be 10, and I want everything that's less. So in order to find that, I want to find the probability that it's greater than 10, so it's 11 or higher, and then subtract that from 1. I'm just going to circle ones that add up to 11 or 12. So here's 2 that add up. These 2 add up to 10. That's not what I want though. Here's another one that adds up to 11. Here's 10. Here's 10. So we have our 3 possibilities. So we have 1 minus, there's 3 out of 36, which is the same as 1/12. So taking that away from 1, using that complement, using the other piece, we find that the probability of the sum less than or equal to 10 is 0.916, and the 6 repeats. I'm going to skip this next slide. We'll come back to this when we do more with cards, but for right now we're going to skip it and we're going to move on to the next one. Okay, the next example, 1 bag of candy contains 15 red, 10 yellow, 6 green. So if you're finding any probability here, your total number of outcomes is 31. I want you to go ahead and hit pause. I want you to complete these, and then I'll have the answers posted in a few seconds. So your bottom should be 31, and here are your answers.